Start Chattan. Carry on.
A very good afternoon to all the dignitaries. My name is Chandana Dhatri from Tribli Department of Vvit. A warm welcome to the second session of National Level Faculty Development Program on Electrical Vehicles, Technological Advancement and Trends. Today we have our chief guest from Vasireddy Venkatadri Institute of Technology, Dr. Y. Mallikarjuna Reddy sir, working as a principal in VVIT, Nambur. Dr. Y. Mallikarjuna Reddy sir research area is wavelets, neural networks, communications, speech and image processing, radar, machine learning in various applications in electrical vehicles. Dr. Y. Mallikarjuna Reddy sir completed his B.Tech in 1987 in Osmania University, Hyderabad. In 1990, he did his M.Tech in JNTUK, Kakinada, and in 2009, he did his PhD in Osmania University. Sir Y. Mallikarjuna Reddy sir published 28 international journals and 18 international conferences, and he has membership in professional bodies such as Life Member in Institute of Engineers (MIE) and Life Member in ISTE (MISTE). He authored 10 books. He started his teaching career in 1990 and worked as a lecturer, senior lecturer, assistant professor, professor head, and vice principal, and now working as a principal of Vasireddy Venkatadri Institute of Technology. Dr. Y. Mallikarjuna Reddy sir received the Best Teacher Award in ECE department on overall academic performance in the year 2004 and 2005 by Vignans Engineering College, Vadlamudi, Guntur, and also received the Best Teacher Award in ECE department for the subject PTSP in the year 2007 by NIET.
Now I will start. Now I will invite.
Now, I request to start the meeting.
Hello, good morning, good afternoon to all.
Good afternoon, sir.
Sir, today in this a 5-day faculty development program on electrical vehicles. Now I'm going to give a brief introduction on artificial intelligence and machine learning for electrical vehicles. So, as you know that today we are going for electrical vehicles, that is converting from conventional working with diesel and petrol and converting into the electrical vehicles. And there is a lot of demand for electrical and electronic engineering students. For there is a scope for having many research areas and innovative technologies that you can develop and to bring the efficiency in the uh, electrical vehicle functioning. Right? So the today contains or that review of artificial intelligence, AI, machine learning and techniques, neural networks, architecture types, electrical vehicles and types, AI and machine learning applications to electric vehicles, AI and machine learning algorithms for electric vehicles. So first of all, to go into the deep of how the electric vehicles are going to build and all these things. As you know that the electric vehicles, it may be starting from the scooter or motorbike or the cars or big vehicles or Volvo buses or trucks, suppose anything that which are is mobile. Uh, as you know that they are going have into many innovations that is going to take place today. So that this artificial intelligence now it is came into the picture, right? Into that in a different categories of the technologies that is taking place on the electrical vehicles, right? So first of all, I will just review on what is artificial intelligence and how the machine learning techniques are used in the artificial neural networks, and how these neural networks can be applied onto the development of innovative technologies in electrical vehicle running. So as you know that the electric vehicle, it is not belongs to one department or one branch. So electric vehicle is a complete system which involves the mechanical parts, electrical and electronic sensors, and including with the software engineering, right? So therefore, it is combined with all these the technologies. Then only we can develop an electric vehicle, right? So, regarding electrical and electronics engineering branch, where how this we can make a more efficient electrical vehicles, and we are going to touch only the part that how the drivings and the energy systems will take place for the electric vehicles. So before that, artificial intelligence and machine learning is the technologies which is developed in the last decades, right, are going to place an important role, right, on how these electric vehicles can be operated. Uh, so just I will take a review on artificial and machine learning so that the participants can easily understand the other technologies, and also they can go into the uh, research areas that is going to be taken place. So as you know that artificial intelligence, it is a machine intelligence, and is intelligence demonstrated by machines, right? So actually the natural intelligence is intelligence developed by human being, as you know that, right? So a human being, we are compared to the other creatures. The human being is separate because he is having a natural intelligence that he can think and he can work accordingly, right? And he can predict the features, or he can do work with the previous experience, and he can imagine, and he can identify, he can work, he can talk, and he can give the answers, and all these things. The how with the natural intelligence by the human being is going to take place. Similarly, missions will have the intelligence called artificial intelligence, and it is completely demonstrated by the missions. And at the last, and these missions are operated by again the human beings, right? So therefore, a systems that can act like humans, or systems that can act rationally, that what we call as a artificial intelligence. So artificial intelligence is a wide wide field, because it is a interdisciplinary course where this can be applied into any fields, right? Any type of field, in agriculture, healthcare, or automotives, or in electronics, or civil, or mechanical, anything, that because it is a multidisciplinary and uh, technology, right? So in the sub part of this artificial intelligence, because there's a lot of algorithms that can be in artificial intelligence, and we have a machine learning which is have a separate algorithms dedicated to a separate that is a specific type of the learnings can be used for different applications, right? And in which a subpart is again is called a deep learning. So therefore, in artificial intelligence is having a wide application, wide area. We are confined to machine learning and deep learning technologies, where we can incorporate in a required systems, right? So to learn this artificial intelligence or machine learning, whatever the computers at present we have, they are not adequate, or they are insufficient, right? Because of they are working at low speeds and low memory, right? And they are not having networks properly, and all, and also not having sufficient software, right? So to enable artificial intelligence in the computers must have the following capabilities. One is called natural language processing. So NLP is one of the very important the processing software is required in each computer. It is to enable to communicate successfully in English, successfully in English. Or we can also have nowadays, they can be communicate in any language also. That is, we are having a language problem. Suppose the Chinese are developed in NLP language, completely in Chinese language, and each is converted into English, right? So there is always that we are when we are speaking English, then it is also converted into other languages also. Therefore, a computer is able to convert from one language to another language. So that must have NLP software, all right, and which is also developed by some Python language or some other programming languages. And second one is knowledge representation. So it must have a knowledge to store what it knows and what it hears. That means that what we are giving the inputs and what we are communicating to the computer, it is going to store and reproduce it, or it is give some other uh, responses to the output. And the third one is automated reasoning. So automated reasoning to use store information to answer questions and to draw new conclusions. Therefore, that means that like a charter, that is, we have seen that recently we got the chat GPT, or that we have the search engines, and this also must be have a computer that you should whatever the stored information that is we are giving to the computer, it gives the answers for the questions what we are giving, and also it is give to the conclusions for that. And similarly, it is having a machine learning algorithms to route circumferences and to detect and explore patterns. So, like this, these are the four important the fields a computer must have. And apart from that, the computer must be very fast. That means that it must have a high data storage system, like the processors like NVDA processors, right, which is having high speed and high handling capacity, and which is having more storage capacity, and also it is working with the cloud-based systems, right? And all this should have a computer. Then only it can run the machine learning or artificial algorithms, right, with high speed. So next you see that how the mission is going to learn the things. We have five important questions, right? So the machine learning, it is do by naturally, right? How we are going to predict the futures by knowing the present conditions or present situations, right? So in these five questions, suppose if you get the answer, then the machine learning will have the algorithms, right? Depending on this. The first one is how much and how many, right? That means that suppose we want to predict the future, that how much we are going to get, or how much the quantity we can represent, or how much efficiency we can get, or how many values we can get. So like that, the future expectations based on the present history or the previous values, that what we call it is a regression. So in the regression, right, it is going to draw the lines, or it going to formulate between the input and outputs, such that if any unknown input is given, then it is going to estimate the output as well, right? And next one is that which category, that is called classification. That means that we can classify the different objects. Suppose the objects we have, suppose squares, triangles, right, or some polygons. Suppose if it all are mixed, then we can classify separately them. Suppose like that image classification, or voice classification, or the classification of different objects, classification of the different things, like that. And that is the category, which category. So next one is the which group, that's clustering. Suppose a particular student belongs to which group of the section, like that. Suppose we have different sections called groups, right? So EC group, CSC group, mechanical group, like that. And we can make them the students clustered, the groups, such that we can estimate the feature of the group of the system. The next one is that is it wild? That means anomaly detection. So anomaly detection is one of the important things that what you are going to detect the uh, unknown things can be detected by using the machine learning technique. And second, third, last one is which action? That is called reinforcement learning. So actually, apart all these five, the reinforcement learning is one of the most important the technique for artificial intelligence, because reinforcement learning it is going to learn the mission by taking the environment conditions into consideration, right? With this, that is, we are going to see that how the machine is going to work, right? Suppose just I will compare the traditional machine and machine learning program with the computer, right? So actually, what we are doing with the computer, so we will give a program, right, as input, and a computer will computes and it calculates the values and it gives the output. And this output again we will give to the programming, and this is just how we are going to execute some programs in the computer, right? So then what is machine learning? So machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. That means that without any program, without explicitly given the program, the computer gives and it will learn, ability to learn the things without explicitly programmed. That means that we will give both input and output at a time, input and estimated output at a time to the machine computer. So this computer will give and it will make the relation between the input and output, and such that it is going to take the program to the outside. So that is we are going to get the machine learning. That means that the program itself it is going to change by taking the inputs and outputs. So therefore, we have to train the computer. We have to train the computer by giving the set of inputs called data sets and with the output data sets. So input data sets and output data sets will have a relationship between them. And with this relationship, the computer is going to learn and store the information accordingly. And then it is going to give a programming system that how to evaluate when an unknown input is given, when unknown input is given to get the predicted output, right? So this is the difference between a ordinary computing system and machine learning computing system. Right? So next, in machine learning, actually there are three important the learning systems. Three learning processes. One is called supervised learning, another is unsupervised learning, and third one is reinforcement learning. So in supervised learning, it is very simple that we have classification and regression models in supervised learning. It involves learning with labeled data sets to produce an output that is generic to that data set. For example, finding the price of a new house given the house prices for a specific location. Suppose, for example, what it is given that, suppose if you go to one area, right, in Guntur, suppose in Guntur, if you go to an area, some particular area, right, suppose you want to estimate what is the price of the house, price of a new house, then what it depends on that? So it depends on the locality and what are the houses already existing and what their prices, right? Suppose if it is having some price, then the new house also which is having nearly equal to that price with the same conditions on that. So depending on the location and depending on the existing houses and depending on the demand on the locality, the price can be estimated, right, with a specific. So that estimation, that what you call is the regression, right? So therefore, in the machine learning, what you do that it will take the data sets for training. That means that whatever the input they call is the label data, right? And it is given directly to the machine learning algorithm, and it is going to learn the system. The system is going to estimate the system. If a new data comes, then it's going to predict the model, and then output is given to be the prediction, right? So that means that if you have some data sets like this, right? So here it is going to draw a, a near fit line. That means that the line is going to fit called mean square error. That means that it is going to estimate the line which is having the mean square error is minimum. That means that it is going to minimize the mean square error between the points on the line, such that a line can be fitted, right, with all the data points, right? So when this line is drawn, then we can estimate of any value of x given, then what is the value of y, right? Suppose here we have only values of x1, x2, x3, x4, x5, x6, x7, which gives y1, y2, y3, y4, y5, y6. Suppose if you give some other data like y8 or y10, sorry, x8 or x10, then it is going to estimate what is the y10 value, right? So by drawing this line. Right? So that is called the regression system. And also we are going to classify the different. Suppose there are the pluses and circles we classify, and we have to draw a line. Suppose if any new values comes, then that may be classified to either it is circles or it will be pluses. So like that we can predict the output. So therefore the supervised learning is one of the most important learning, that it is going to learn the data sets given, right, before for the estimation. So the machine will learn with the input data sets, and then it is going to make some programming in the storage memory. If any new data or unknown data is given, then that with that new data, it is going to programmed predict the model output, and then it is going to predict the output. Right. So this is called supervised learning. And next one is that unsupervised learning. So in unsupervised learning, so we don't have any previous data or the data to be stored, right, and to data to be labeled. So here it involves to find the connections between unlabeled data or clustering the data, unlabeled data or clustering the data. That means think a bunch of images that are not labeled but have parameters like color, size, etc. And the program will return a result of whether the image is a fruit or a animal. So here there is no labeled data, means the previous things is not known. But here what you are going to give, that we are going to give a mixed objects. Suppose some fruits or some animal figures or some other figures. There's a different colors, with colors or with sizes or with the shapes like that. It is given to that. Then what the machine will do, that it is going to separate them. It is going to call cluster. It is going to separate them into the different categories. Suppose if red color fruits are there, it will separate red color fruits. Suppose it is a blue color fruits are separated. If it is green color fruit, fruits are separated. So in the fruits again, suppose if it is grapes separated, banana separated, so like that, it is going to separate depending on its size, its shape, its color, and whatever that. So that we call it as a clustering, right? Suppose if any unknown shape or unknown color or unknown thing is there, then it is going to estimate and in which cluster it is belongs to, and that is given to the output. Similarly, the dimensionally reduction technique is also one of the unsupervised technique, where it can reduce the dimension from high dimensions to low dimensions, or high dimensions to low dimensions, such that we can easily estimate the output very easily, right? So this is called unsupervised learning. Next one is that reinforced learning. So the reinforced learning, actually it is the most important the learning technique that is involved in artificial intelligence, right? So it is different from supervised and unsupervised learning. The most common form of it is the most common of the common form of the Merling's. It is not that. It uses experience-driven sequential decision making. This method interacts with the environment to learn and move towards a goal that towards the actions taken, right? So what is that? A supervised learning, it is having in the diagram, what it in the reinforcement learning, it is having decision process, reward system, and a learn series of actions. So it is having a two systems. One is called agent and environment. And agent generates the states to environment, and the environment it see the agent for the action. If it is yes, it is going to reward the function for yes or no. Right, when you take the action. So it is just like that. Suppose a child is growing, right, and he learned for looking into the environment and for his surroundings. So how a child is going to memorize everything? Suppose actually in the beginning he don't know what is fruit or what is animal or what is chair or what is thing. But when you want to tell the child that this is a fruit and this is the pen and this is the paper and like that, then the child is going to learn all these things by looking into the environment. So therefore, in the mind, all the items, whatever he learned, right, in the environment, that he will memorized, right, and he will learn that how it is going to act like that. So by this action, right, and we are going to reward the system by identifying the particular thing, right? Similarly, the machine also will do the same thing. How the natural intelligence is going to done with the human being. The same thing, the machine is also going to have an artificial intelligence algorithms, right? It is going to learn all the systems, all the things, all the its surroundings, what is going happening, and everything that is giving to the input. Right, with the input, it is going to learn all these things, and then it finally it is going to give the output. Suppose, for example, a chat GPT, recently it is came that, so what is going to that, you are going to learn all the inputs, all we are giving to the inputs to the chat GPT. And suppose if you give any question, then it is going to give a particular answer, right? So that answer, how it you are going to get the answer, that means that it is going to analyze the question, what the question you are giving, and analyze the question, and then it is going to search the answer what it is learned already, and from the learning that it is going to draw the answer sentences from the learning point, and these answer sentences will be combined and make it to a single sentence, and the sentences comes as a page to the output, right? So like that, it is the artificial intelligence gives the main the part, right, in reinforcement learning. And this reinforcement learning is very, very important in electronic vehicles also, right, to know the routing, right, with self-driving cars or with the driverless cars also, right? Suppose without the driver, the cars will take the decisions of the road and mapping and everything, right? So it is going to do that, right? So this is about the artificial intelligence and this. So all this intelligence, that is the main part of this is called the neural networks, right? So the neural networks are developed uh, from the brain, how the brain is going to work. All right. So actually, we know the working of the brain, right, and it having a neurons, right, and these neurons are having synapses, and the input it takes as the tetroids and the weighted sum, and this is already have studied about the neural networks in your BTech programming, right? So which is having the function with weighted values, with the inputs of taking weighted values, and the cell body, it is consist of the sum of all these things with bias, and you have the activation function. This activation function gives the output of this. So the neural networks, now we are calling it as artificial neural networks, is the main important the building blocks for the uh, machine learning and artificial algorithms, right? And how these building blocks is going to work, right? Which is you already studied in the neural networks, right? So these neural networks can be right having different structures. We have the different structures of network, and how these neural networks are going to work and all this. So how these algorithms what you develop as a neurons, right?
பையன் தூக்கல அவன் தூக்குற வரைக்கும் எங்க வெயிட் பண்ணிடுவாருன்னு சொல்லிட்டாரு நானு.
So in neural network archetypes, we have different types.
எனக்கு இன்னைக்கு குளிக்கிற ஒப்பிக்கலாம்.
நான் நினைக்கிறது என்னதுனாக்கா,
Hello? Hello, is it audible to you all?
Yes, sir, it is audible, sir.
So some noise is coming in background. That is check there. No? Okay. So the neural network archetypes, we have different types of neural networks called perception model in neural networks, radial basis function neural network, multi-layer perception neural network, recurring neural networks, long short-term memory neural networks, right? Half-field networks, half-field networks, Boltzmann mission neural networks, conventional neural networks, modular neural networks, physical neural networks. So these are the sum of the architecture of neural networks and how these neural networks are interconnected. That you are taking as a neurons which are going to develop that, and they are interconnected. It's called a single layer, and we have the multi-layers of neural networks, and these networks are connected with weighted sums, and we are going to take the output of this, right? So which have the green, it indicates the input unit, and orange color is the hidden layer, hidden inputs, and blue is called the output unit, right? And backfield input neuron. That means that we are going to give the back to that, and we have the different structures of neural networks. But here we are not going in depth of what is neural network and how we are going to learn, because this have the basic ideas already known. That is, we can easily study it from the like a curriculum, right? In BTech or MTech curriculum about the neural network architecture and how they are going to implement and what are the different types, right? So therefore, we are not going to study about the neural networks here. So but now we are going to these structures, right? The neural network structures that is used to develop the algorithms, right? For getting the different the outputs of the electrical vehicles. So now we are going to the switch on to electrical vehicles and how these artificial intelligence, machine learning, neural network techniques can be applied onto the electrical vehicles, and what part of electrical vehicles we can use that, right? So that is already I told you that the electrical vehicles, right? Which are having a different structure, right? That is come from mechanical and electrical, electronics part, and also have the software engineering. But we are going to see the part of how this electrical part, right, is going to develop in the electrical vehicles, right? So next we'll switch on to the electrical vehicle and what are the different types of electric vehicles that you are going to see them next, right? So as you know that electrical vehicle, as it is visible to all, Bhakta Singer is visible. Hello,
Hello, sir. Yes, sir.
is it visible?
Yes, sir. Visible, sir.
Visible, right? Right. Okay, okay. Because the diagrams are very small, whether it is visible or not, I don't know exactly, right?
It is visible, sir. Clearly.
Okay, okay, right, right. So electric vehicles types. As you know that electric vehicle runs on electric motor. So this is very simple, right? So any vehicle, that is, it is a bike or it is a scooter or it is a car or it is a three-wheelers or two or four-wheelers or any type of that. The the wheels are run right with the electric motors rather than IC engines. So usually, what is powered by petrol, diesel, and gases, right? We have that internal combustion engine as in a traditional way. IC engines, right, or take the burning of a mixture of fuel, petrol, diesel, gases, and all these things, and from that it is going to get the power and it is going to run the wheels. But in electrical vehicle, right, it is just there is no intercombustion engine or there is no nothing, but it is having only the electrical motor, and this motor is going to run the wheels of the electrical vehicle. But it is the main thing that, and what are the different types of electric motors are available at present, right? So we have a completely battery electric vehicle that is called BEV, battery electric vehicle. The next one is hybrid electric vehicle, that is HEV. Next one is the plug-in hybrid electric vehicle, that is VHEV. And the fourth one is fuel cell electric vehicle. So the fuel cell vehicle. So these are four important types of electric vehicles at present in the technology it is going to run, right? So now we have seen that how these are explained in the diagram. So in the diagram, see that battery electrical vehicle. So in the battery vehicle, suppose these are the four wheels we have, right? And the four wheels we have, and we have a battery pack system, which is fully charged, and it is kept into the inside the vehicle. And this battery gives the electricity, and electricity is connected directly to the motor, and his motor is a motor, maybe it is a AC motor, right? So the battery that is going to have the DC, and this DC is converted into the AC, and AC induction motors generally we are keeping here, and it is have the geared with the wheels, right? So the gear control and the control mechanism of mechanical and everything will be built here, and we have also a regeneration that is called a brake regeneration also is there. Suppose when the battery is when the motor is running, and we can also give to the reverse way such that the motor is going to generate the electricity that is connected to the generator. So the motor is connected to the generator that is going to give the AC, DC, right? And the DC is going to charge the battery. So the degenerative system will improve the battery storage system also, right? So therefore we have a directly connected to the drive, and also we have a regenerative mechanism such that it is improves the battery charging time. So this is completely a battery, right? So therefore the battery is required the external electricity, right, for the charging. For the charging the battery, we require the external electricity. So therefore, when the battery is discharged, then you have to give the charging to the battery every time after discharging, right? That is after every 100 kilometers or 200 kilometers, 300 kilometers, depending on that. So it is a completely battery vehicles. Next, we have the hybrid electric vehicle. So in the hybrid electric vehicle, it is also one of the important system at present, right, we are running. So here it uses no external electricity. External electricity is not required, but it requires the fuel, right, either petrol or diesel, just like a conventional vehicle. It is having a fuel system that is connected to the engine, and this engine is going to drive the wheels, right? And also it is consists of a battery, right? And this battery is charged by the regenerative system, that is the from when it is running on the fuel. When the vehicle is running on the fuel, the battery is having a regenerative system. That means it is having a generator. That generator is going to charge the battery when it is running on the fuel, right? So when the battery is fully charged, then it is connected to the motor. Then motor is going to connect to the wheels for driving. So therefore, it is driving on the battery system, right? So when the battery is charged, so it is on the battery. The vehicle is moved with the battery without fuel. When the battery is discharged, then automatically it switch over to the fuel system. Then the fuel is going to give the power to the wheels. Then the vehicle is smoothly running in the interchanging, right? and at the time of the vehicle is running on the fuel, it is going to regenerate the electricity, and that is going to charge the battery. So this system is called the hybrid system because we are using the fuel system and as well as the battery system. So for example, recently we have Tesla cars and Toyota cars and Maruti Suzuki, right? Grand Vitara. So these are cars are called at present we are having called the hybrid electric vehicles. So they are running very successfully. And similarly, we have another that is called plug-in hybrid electric system. So in the plug-in electric hybrid system, actually it is have the both electricity as well as the fuel, right? But only one difference is it is also going to take the electricity from the outside, from the external is required to charge the battery, such that it is going to charge very fast, right? Fast charging is takes legs. So, but this type of system is required for heavy vehicles, heavy type of vehicles called the plug-in type, right? Where we can have the battery charging from the fuel also as well as from the external battery. Both also be used. And the last one is called fuel cell electric vehicle. So fuel cell electric vehicle is completely an advanced technology that is it is not yet commenced. In the forthcoming, right, by 2030, that we are going to get the hydrogen fuel cell. So in the hydrogen fuel cell, it takes the hydrogen gas right into the tank, hydrogen tank, and this hydrogen fuel cell we have that hydrogen is converted into electricity, and this electricity is going to charge the battery, and this battery is connected to the motor, right? So therefore, this is the driving system that we have right from the electricity, right? So these are the four types of the electric vehicles. That is at present we have a lot of the challenges and successfully running the systems. Right? So next one is that we are going to see that then how this artificial intelligence and machine learning are applied to electric vehicles, and what are the things that we are going to design by using AI and ML techniques, right? So electric vehicle cost reduction. That means that one of the important thing is the reducing cost, right? So it is going to reduce the cost, optimal battery material design and manufacturing. So one of the important part in the electric vehicle is that the battery pack, right? So the battery material and design and manufacturing. So how the battery is designed and what are the materials are used, how it is manufactured, and it is very cost effective, right? So when you are using AI and ML technique, then we can reduce the cost. We can reduce the cost of manufacturing by optimal utilization of mm, the material and manufacturing techniques. The next one is accurate range estimation to mitigate EV consumer range anxiety by predicting future driving conditions. So if you know the prediction of the future driving conditions based on the driver, how the driver is driving the car and all those things, then it is going to estimate the range, right? At what range the battery is going to exhaust, the battery is going to die, right? Suppose if the battery is completely exhausted, then the battery vehicle it cannot move. Therefore, there is such a range anxiety in the drivers such that for what distance the battery charging comes, when it is going to discharge, right? And where is the charging station, or and what distance that you have to go for charging and all these things. So therefore, we have to use this AI and ML techniques to accurately estimate the range, right? And to give the customer that. So within this range, then you have a, a station that we can easily connect to that. So therefore, the driver can predict the future driving conditions. And second, the third one is improved EV energy consumption. So electric vehicle energy consumption is going to improve versus the traditional controls using AI controls for EV auxiliary systems. So therefore, we can have you can have the AI control system, artificial control system, and it is going to estimate how much the energy is consumed and how much it is going to. Therefore, it is going to improve the energy consumption. The fourth one is a potential for increased road safety and optimal traffic control through connected and autonomous driving. So it is going to also increase the road safety and optimal driving by using AI-enabled techniques. Right, a thorough and efficient molding approach for optimal location and resource allocation for electric vehicle charging stations, because that electric vehicle charging stations are very important, that and where it is located and what is the distance of a location, right, and everything will be scheduled, right, for the energy scheduling for electric vehicle interaction with the smart grid, and these are all things we can do with AI and ML techniques. Suppose now we see that how the machine learning is going to do with these techniques, right? There are different techniques that is called a reinforcement technique, which is already I told you that it is having environment conditions. It is going to take the state and going to the agent. It is going to give the action and then give the reward as the output to the agent, right? So therefore, here we can also apply a deep learning technique. We call it as a convolution layers and pooling layer, and fully connected neural networks can be used on these techniques. And also you can use the LSTM technique, that is called recurring neural networks, RNN. RNN can be used to take the different output for the input. And also you can have a computational intelligence called swam intelligence, that is to predict the nature and how a fly can identify its prey, all right, by looking to the different directions and move to take the direction and identify the object, right. This is called swam intelligence, right? And also we have the evolutionary computing, that is the computing by using fuzzy logic techniques. So the fuzzy logic is also one of the important technique that can be applied in the artificial neural networks, right? For fuzzy logic, right? By using this fuzzy logic technique also, we can implement these algorithms. Therefore, these machine learning algorithms can be used, right, in the optimization of the different techniques that is used in the electric vehicles. And the next one is that AI in artificial neural network in electronic vehicles, right? So in the electronic vehicles, that is, we have take the safety, reliability, and economic feasibility of electronic vehicles are critical for their mass adoption, and those properties can be significantly improved through the implementation of AI. So this is very important, that when the electronic vehicles are designed, the safety, reliability, and economic feasibility are the very, very important factors of that. So the safety mean, so how much safe the electronic vehicles are, right? So in different conditions, because when you are using the battery system, sometimes the battery may explode, right? Because of the temperature, heating temperature conditions, or the battery it will not be work properly, right? And reliability, how much it is reliable, right? So when you are using the motor system and uh, the developing of the battery pack, right, for this. So safety, reliability, and economic feasibility. That means we have to see that the cost of the electric vehicles, the cost of the vehicle, it should be feasibly available, economic feasible. So are these are the very critical for the mass adoption, and these properties can significantly improve through the implementation of AI. So artificial intelligence can be applied on this vehicles such that a human being can, a driver can easily interact with the vehicle conditions, and uh, he can use very safely and with high reliable and with low cost, that is economically feasible values, right? So therefore, to get all these things that explanations, the applications of AI in electric vehicles have divided into several categories. So in the entire mechanism of electrical vehicles, the part of electrical and electronic, that is sensor that we are using, that is separately. So from the sensors we are going to get the different signals right to the electric vehicles, and but we have to concentrate more on the electric vehicle battery design. Battery design is one of the important, and manufacture and management of the batteries manufacturing, battery management, and also you see that the motor conditions and motor driven techniques. So there are, we require a different the mechanical parts as well as the electrical drives. Electrical drives are required for driving the electrical motors, right, with different speeds, at different speeds, right? And because there is no gearing system here, because all the electric vehicles are work on the automatic gearing system, right? So there is no gears, so only the driving mode it is going to go that. So when the motor is on, that is going to switch on to the different speeds of the motor, right? So therefore, we have to get the different energies to drive the wheels of the electrical vehicle. So the initially you go for the range optimization. So the range optimization can be used that suppose you want to go for the 50 kilometers distance or 100-kilometer distance. So depending on your range requirement, that you have to optimize this range right with the fuel efficiency. That is how much the battery is going to discharge. So to go that much of distance and all these things. Right. Similarly, we have the control system design and optimization for energy efficiency management. Right. So these are the four important the directions that we have in the electrical motor system, electrical motor and battery connection system. Right, where we can use the artificial intelligence and machine learning techniques. So that is we can have in depth. The AI has been utilized for battery R&D. So recent development of the battery. That means that to improve the battery performance, the battery pack material management and energy management. So the battery development, that means that the battery uses the different materials, right, to produce the high density, high energy densities. That means that the battery should be a lightweight, right, and small size, and it must be in compact. That so you have to make the battery modules because the batteries are connected in parallel to get the final battery pack. So this battery pack wholly give a sufficient voltage and current requirement to the motor, right? So therefore, the battery pack management is very very important, such that we have to see how many batteries we have to make it pack, and what is the space available, and what is the cost of the battery modules that will be to be connected, and how much energy is required for a given vehicle. Suppose the different vehicles will have the different energy management. Suppose, for example, scooter will have some energy, motorbikes with having the different speeds and different ranges, and also the two-wheelers, three-wheelers, or bus or heavy vehicles, heavy load vehicles. They have the different energy management. So depending on that, we have give the battery package management. The different types of batteries are required. So therefore, artificial intelligence will be perform will give the it will going to give and improve the battery performance and management system. And similarly for electronic vehicle control systems, right, or charge stations. Suppose you see that EV charge stations, the optimal EV charge stations replacement, congestion control, rival energy scheduling, right, and the efficient energy management during two-way energy transfer between electric vehicle and smart grid enabled by grid to vehicle and vehicle to grid. So when you consider the electric vehicle charging station, a charging station is having the electricity, right? It is going to charge the vehicle by plugging the system, that is electric vehicle. So from the grid, from the electric, because it must be a two-way system, that the charging system will be enabled to grid to vehicle connection and vehicle to grid connection. This is the two-way system. That means that the batteries are going to charge from the grid, right? And similarly, if the vehicles are not in a working position, that is the charge can be connected to the grid. That is the vehicle to be connected to the grid. That means that electricity can give to the back to the grid if we have a renewable energy system in the vehicle. Suppose if it is work on the hydrogen system, that electricity whatever it is generated in the hydrogen through hydrogen system, then we can connect it to the grid. Or if the vehicle is connected with the a solar system, the solar energy that we are connected to the electricity, and that we can give to the grid system also. So therefore, the charging electrical vehicle charging stations must have a two-way connection between the input and output, right? So it is use the two-way system. So next, we see that how this is the smart grid interaction, and how artificial intelligence is used in electrical vehicle charge system, and electric vehicle integration with the smart grid. And this is given in the diagram. Suppose this is the block diagram. In the center we have AI system, artificial intelligence system. So this artificial intelligence system now it is going to the connected to the vehicle, all right, and it is electrical vehicle. The first one is we have going for the battery R&D. Just now I have explained about the battery R&D. So in the battery R&D, it is going to take the material discovery and manufacturing and characterization, right? So in the battery R&D, it is going to say that the battery R&D, it is going to take that materials are very important. That means the selection of material is very important, such that it is going to improve the energy per, that is called energy density. That means the more energy to be given with a small area of the battery system, right? Such that it has to going to find out what a suitable material for a battery, suitable material for battery. So for this, there is a data set is available with the different materials, right? And the different energy densities to be covered. So therefore, this data set can be used in the machine learning, and to select the better material suited for a particular vehicle. So whatever the vehicle that is going to that, what is the material is going to use, and how this material can be utilized, and everything that will be given to the in the battery management system, right? And similarly, battery management and routing optimization, right? So it is having a state estimation and a diagnosis, charging control, and range estimation. So in the battery management and routing optimization, you have the three: state estimation, diagnosis, charging control, and range estimation. Right. So these are the things that will be developed. All these things can be developed by artificial intelligence techniques to improve this technologies. And next come to the two-way charging system that are called grid to vehicle charging and vehicle to grid charging, right? So in which the electric vehicle integration with the smart grid will be takes place. So therefore, artificial and machine learning algorithms, right, are used to for scheduling the energy and scheduling when the battery degradation issues. It takes the battery degradation issues, modeling consumer and the charging habits, and all these things will be carried out by the grid to vehicle and vehicle to grid systems, right, by using artificial intelligence. And the second and third one is that uh, electric vehicle charging station. So the charging stations are required to charge the electric vehicles when the charge dies, right? So before the charge dies, the electric vehicle to reach the electrical vehicle charging station, and it may be home charging also available when it is when if you go to the home, we can also charging station for home because it is only just a charger. If you purchase a charger with battery, so that you can be a control at the home charging station also you can be it. And at the routing at the different routes, right? Electric vehicle charging stations are required at all the ports. So the energy congestion management, energy scheduling, congestion management, and smart charging. And these are the important the techniques that is going to use at the electrical vehicle charging station. So the optimal location placement is very very important for the charging station. So these are real thing that will be can but it can be done by artificial intelligence and machine learning techniques, right? Can be used. And suppose, for example, for uh, this is one example how the materials is available for the battery. Battery materials are available and a different a combination of a chemical. This is called the chemical heat up and potential materials discovered in the machine learning techniques. This is one of the examples sir, where the machine learning techniques are used to find out. This is map is called heat map. The available chemical heat map, the suitable potential materials discovered by the machine learning technique. And similarly, the energy storage capacity, voltage, and parameters we can be calculated by using DSP algorithms called the DFT, Fourier transform techniques you can use, and you can calculate the exact design of a battery size. That is the free energy diagram and descriptor and effect factors. So these are some examples are given that the DFT calculation for energy storage and conversion. These calculation can be used to find the relevant electronic properties of the materials for machine learning training and testing, data set training. So data setting trainings are used. Some of these examples. So this is some research paper where they are going to give the some output on how to select the materials for the battery for a high density battery system. That is the battery system that is we can adapt to this. Right? So machine learning in battery R&D. So as you know that the batteries, lithium-ion batteries that present we are using, right? So this is the lithium-ion is one of the revolutionary techniques compared to the previous batteries, because the lithium-ion batteries have heavy storage and high energy density, and it give long life, right? And the discharging times are very fast. Charging are very fast, and discharging is very slow, and plays an important role in providing the power source and energy storage for electric vehicles. So for all electric vehicles, we are using lithium-ion batteries only at present, right? So these lithium-ion batteries are available with the cell of each having some voltage, right? Minimum voltage. So therefore, when you want to get the more voltage and current, that we had to use a electric vehicle battery pack. So this is a battery pack. It consists of a multiple number of batteries connected either is in a series or parallel modules, right? So these are called modules. So the individual batteries are connected and assembled into battery modules within a turn are connected and assembled into battery pack. The combination of series and parallel connections of the batteries within the module and the modules within the battery pack provide desired potential and capacity. So to get the desired potential and capacity, we can use these batteries as a battery pack, right? And this battery pack will be differ for different uses of the electric vehicles. Suppose for small capacities, small electrical batteries are used, small pack, and for big vehicles, suppose cars or trucks, buses, so they require a large power pack, a battery pack. So therefore, battery modules are used a battery pack. So at present, what are the issues? That is, what are the challenges that we have occurred in the battery pack means? We have some barriers in battery design and manufacturing to the battery management and optimization during operation. So in electron vehicles, the limitations are battery design, manufacturing, and lead to low energy density of the electric vehicle batteries, resulting in increased production cost. So one of the current issue is the production cost is very high by using the number of modules in a battery, and also the battery lifetime is also very small. That is comes to 6 months or 1 year. Again, you have to replace the batteries. So therefore, it is the production cost is very high. So therefore, to reduce the production cost and to increase the energy density, that is energy per, and to make it lightweight, right, with less occupancy of this battery. So we are using machine learning techniques to that. So a machine learning technique can be provided to overcome the performance related challenges like low energy density of the electrical vehicle battery pack by facilitating battery material discovery, characterizations, and improving battery manufacturing efficiency. Machine learning can lead the way to high battery energy efficiency and safety and improve consumer uh, perception of electric vehicle range. So therefore, now we are going to have some innovative techniques can be applied because the present issues without using machine learning and artificial intelligence techniques, those can be overcome by using the machine learning techniques, right? But at present, it is in the research, right? In the research, and they are doing the many innovative techniques they are going to apply. So within in the future, right, in the next by 2030, then we have a good a type of batteries will be available for the batteries that is we can go to right, have the improved versions of battery technology also comes, right? So at present we are facing a lot of problems with the batteries, right? But in future maybe other techniques may comes, right? Like hydrogen cells can be used instead of the battery, lithium batteries, right? But presently lithium batteries are very high, very safe, and very energetic, and with having very high energy, and these batteries will give a long life, right? And whatever the technology at present we are using, so they are using for that, but they require more times of charging, right? Charging is one of the limitations of that, right? So therefore the ML technique, the machine learning, what you have that we have a less capital and time intensive approach for battery material discovery and characterization. Efficiently explore the chemical space for new material discovery for high energy density and safe battery electrodes that can be used. And account for complex molecular interactions, reaction pathways, and minimization of side reactions. These are the one of some of the that is techniques we can provide by machine learning. So therefore, at present, suppose if you go to the Kaggle data sets, therefore there is a data set is available already in the Kaggle.com in the Kaggle challenge, right? And these data set can be used, right, to make and to produce a better life battery, right? And these data sets are available in the Kaggle is called Chemical Space Project. Another is the QM9. So QM9 is one of the important data set that is available in the Kaggle for public, and we can use this QM9 data set and using this QM9 data set, we can train the machine learning techniques, right? To machine learnings are frequently employed to predict the anticipated properties of new materials. That is to predict the properties of new materials from the unknown properties by exploiting the trends of the existing known materials in the database. So in the database, it is giving already the existing known materials, right? So the QM calculation database, that is QM9, are used to estimate the chemical properties which are hard to measure experimentally or unknown, or of existing materials, and these chemical properties are used as the input to the machine learning techniques. So by using this machine learning technique, that is, we can incorporate right in the using these data sets, we can train the machine learning algorithms to get the better chemical properties of the battery, right? So just like you see that how the batteries management of the ML in battery management. So we have a battery management system, right? That is used for the battery. So here in the diagram you see that the electric vehicle battery pack. So this is the battery pack where the batteries are packed, right, in a module, and these have the number of batteries are connected either in series or in parallel. So from this battery pack, we are going to take the different parameters called pack voltage, pack current, and the cell voltage, and different temperatures, right? So by taking this, right, in the packing, we are going to have the state estimation, right? So because that the battery is responsible for battery pack sensing, battery state estimation, safety, and diagnosis, and ensures energy efficient control of the electric vehicle battery pack. So as shown in the figure. So in this figure, we have the two important outcome. One is called state of charges, SOC, state of charges, and in the diagnosis we have state of health, that is the fault detection. So the fault detections and the state of charge, that means that how much it is charged and how much it is going to charge, and what is the discharge conditions, and the charging controls. That you have the charging controls to prevent overcharging and undercharging. Overcharging and undercharging can be prevented, and this is everything that is we take into the machine learning techniques. So these machine learning techniques also can be used that uh, we are going to calculate the temperatures, right? That means we have to see that the temperature must be recorded within the range, right? And the battery pack SOC and HOC estimation are challenged by non-linear battery characteristics, because the battery characteristics are non-linear within each cell, and inconsistency in performance between them, in which machine learning and EOC models are combined and can be used with higher SOC and SOH prediction accuracy and low computation resource requirements, right? So therefore we are using a deep learning model techniques. Deep learning techniques, we are combining with the ECM with the deep learning model technique, and use the RNN, recurring neural network techniques. So gives the model of the recurring neural network, which is having one input layer and hidden layer and the output layer, and have the recurring technique. That means that the layers are taking an output as a biasing the input, taking to the input and comparing the previous history, that is having the storage system here. And this RNA technique is very suitable, right, in the battery imaging system. So therefore, there is a data set is available in publicly in Kaggle. The public available battery data sets used for SOC estimation are NASA Acme data set and Kalke battery group and Savarsan. So these two are popular data sets that are available in the public, and they can use these data sets, right, to estimate the battery pack management, right. So therefore here we can also use recurring neural networks, which includes the RNN gated recurring networks, RNN GTU, and long short-term memory LSU units, right? And it can be effectively capture the long-term battery characteristics also can be it can be used, right, for the battery management system, right? So therefore, the battery management system, which will effectively uses this machine learning and AI techniques, right? And using them, we can have a lot of research on it, that you can find out best battery package model, right, for the different applications, right? So next you see that range optimization. So range optimization is one of the very important that technique. Besides of battery management system, the range optimization during electric vehicle driving can be a tremendously increase energy efficiency and saving driving time. So energy efficiency and driving time, that will be shared by range optimization. So range optimization means that you have to see that, and in the range optimization means that you have to see the estimation of the range, right, compared to the battery charging, right? Suppose a battery, if it is fully charged and it comes for some distance, then how we are going to estimate the distance, right, for the discharging of the battery. Suppose if the battery is discharged in middle, then you cannot move your vehicle, right? And you have to go to the nearest charging station, right? To estimate where the nearest charging station, or estimate to the house, or estimate to the destination, and these are things will be come under the range optimization techniques. Right. So therefore, in general, range estimation is a step to achieve electric vehicle range optimization as one of the most important research areas in electric vehicle today. An accurate range estimation can largely mitigate the range anxiety faced by the electric vehicle drivers. Because of limited driving range, electric vehicle drivers can make effective driving, parking, and parking and charging decisions, and participate in more vehicle to grid charging. However, conventional RE methods are not always accurate, mainly from the disregard of dynamically charging external and operational conditions. So, the vehicle to grid charging, that is, the vehicle to grid charging also is going to take place from the renewable energy sources. Right? This also takes place there, such that we can have the range estimation computed. So, AML technique. AI and ML algorithms, including machine learning, can be used to accurately predict the future environmental and driving conditions based on past and current conditions. These features predicted the conditions can be used for more accurate range estimation. So therefore, more accurate range estimations can be predicted, right, accurately by using AI and ML algorithms. So these algorithms can be available in the GitHub challenges or GitHub websites. If you go to that, then you can find out more number of algorithms, right, for the range estimation of range optimization and estimation of the electric vehicles. So next one of the very important the part in the electric vehicle is control systems, right? So these control systems are used right in the vehicles. One is from battery to the power drives, and power drives to the motor, that is the induction motor, and induction motor that is connected to the power steering, and also power steering that is connected to the wheels, and motors are connected to wheels, right? And for all these things, we require a control mechanism. A control mechanism is required to move the vehicle at different speeds, and in a drive mode or reverse mode, and whatever in that. So therefore, it is a very essential The electrical vehicle control system plays an essential role in electrical vehicle hardware's energy consumption and thus can indirectly impact the electric vehicle driving range, right? And the optimal electric vehicle control system use ensures a reduction in energy consumption of electric vehicle hardware, including power steering, regenerative braking, and internal environment hardware controls such as HVAC, heating, ventilation, and air conditioning, while maximizing vehicle speed, right? So when you have in suppose when you take a big vehicle, right, and in the big vehicle you see that there is a lot of heat is generated from the motors and all these things. So therefore you require a lot of ventilation and air conditioning. For air conditioning also you require the energy, electric energy, right? So for all these things we require a control mechanism, right? Particularly the regenerative braking system. Regenerative braking system is used, right, charge the to charge the batteries, right, from the motor, from the motors, right, when it is not in the driving mode. Suppose in the driving mode the motor is running, then it is going to use to charge the battery, right? So this type of regenerative braking system is available in most electric vehicle models. It is provides an opportunity for energy generation for increased driving range. So it is going to increase the driving range because the batteries are again charged. Therefore, charging is going to increase the batteries from the motor regeneration. So the RBS regenerative braking system converts kinetic energy into useful electric energy when the vehicle slows down, thereby extending the range of the electric vehicle driving technique system. Temperature and ambient temperature affect the efficiency of energy extracted from the RBS. So therefore, RBS is one of the important the system, right, for the regeneration of energy. The electric energy will be regenerated and given to the battery, and again battery it is connected to the motor. So therefore, what are the electrical control system that we are going to use this year, right? We are using a charging system and battery management system and electrical propulsion system that we have that, and is connected to the agriculture system, HVAC, and brake system, that is the hydraulic brakes, regenerative brakes, and power steering. So these are the every system will have the control mechanism. And with this, in the conventional, we have PID controllers are used in the conventional system. But when come to the artificial intelligence, then AI system, that is AI artificial intelligence control system that is used here with upgrade provision and protection system that you are using, upgrade system with the PID system is added here. That is the artificial intelligence controls involving AI techniques such as fuzzy logic, neural networks, and evolutionary algorithms. Can be either used as a can be either used as a substitute for an in conjunction with conventional industry controllers such as proportional integral PID. That is the PID controllers are used. Among current optimization strategies for EV control systems, AIC, artificial intelligence controls either exclusively or as an AIC PID hybrid model or resist as emerging and smart choice for EV control system design and optimization to improve the energy efficiency and further relieve range anxiety and further relieve. So AIC system is having function and of fuzzy interference rules and de factorization and the process system. So this can be used as the artificial intelligence control. So this control system is having a wide area where you have a lot of research can be done to improve the entire control system of electric vehicles, right? So the electric is very important here. It will be takes place such that the machine learning techniques can be applied on the control system, right? To provide accurate with high efficiency and high energy efficiency, that is, and optimization design of the control system can be used, right? So this is how a wide area of research can be done here, right, in future, right, for controlling the entire electrical parts of the system. So next one you see that the next one and last one is the artificial intelligence in electric vehicle charging station. So the charging station is very important one for electrical vehicles, right? So the how the charging stations are used for charging the electric vehicles, right? And what are the voltage levels, and how we are going to location, that is called optimal location, where you have to locate the electrical stations depending on the um, traffic and depending on the number of electrical vehicles available, all right? And all these things will be done in the electric vehicle charging station management. So prediction of the optimal location, and prediction of the optimal location, one of the important ways to reduce the electric vehicle to reduce the electric vehicle user range anxiety in the optimal placement of electric vehicle control stations, namely optimization of charging locations. So optimization of charging locations where you have to change it. So this placement will give the user more confident in using electrical vehicle, given that the user has a high chance of finding an electrical vehicle charging an electric vehicle charging station before the electric vehicle battery dies. So EVCS are classified based on the charging voltage provided by the charger, and these categories are. So we have a level 1 charging station which provides a 120 volts. So 120 volts charging station, it gives the battery package of having 120 volts, all right, and is going to charge for lower distances. So maximum it is covers of 50 kilometers or less. And this is used mainly for less power consumption vehicles such as two wheelers of this 120 volts, right? So the charging also very slow, right? So it will take 6 hours or 8 hours for charging the batteries. So therefore, mainly this type of charging stations can be kept at home, right? So such that you can keep the charge in the entire night, such that in the morning it will be charged fully, right? Or in the parking stations. Suppose in the parking station, if the vehicles are parking for long times, then level one stations are used for charging. And second one, level two. Level two is the 240 volts. 240 volts charging stations are used, and these are the moderate charging stations for three wheelers or four wheelers. Next is the DC fast charging, that is about 400 volts in case of Tesla superfast station. Suppose a Tesla that is using a 400 volts superfast charger, so within 2 3 hours, the battery will be charged fully, right, and it will go to run more than 250 to 400 kilometers of distance, right? And recently, the Tesla and Toyota, and they have discovered one another charging station called 800 volts battery system. So 800 volts charging system, it is called the super fast charging station. So within half an hour, the entire battery will be charged, right? And it will come more than 500 kilometers of distance, right? And these supercharge stations also have the cost effective because they are very high costly these stations, and will be kept only some important stations where it is required, right? So depending on the types of charging stations that you have to provide these type of charging stations depending on the availability of electric vehicles and their density of a number of electric vehicles available in a particular route, right, or in the particular area, right. So depending on that, we have to provide the that is the range estimation. Range estimation also will be provided on this, right? So to gain wider EV acceptance and provide user convenience, Tesla, because you now at present you see that the Tesla, they have installed about the Tesla installed about 1,900 electrical stations, right? 1971 DC fast charging stations globally, right? So 11 electric vehicles with long charging times and are usually placed in parking lots, whereas the DC fast electric vehicles are placed near high volume road acceptance points. And optimal placement of electric vehicle consumption depends on several factors such as the local charging demand, the construction, feasibility, a road network, and other infrastructure optimally and electrically, and operating economy and power grid security. So optimal for placements of electric vehicle chargers generally formulate in the multiple object optimization (MOOPs) and function with the objectives compromising maximization of cost effective and maximization of net presence value (NEP) and or a preference to unpopulated areas. So these are the important upcoming the electric vehicle charging stations. So at present there is a lot of research is going on, right, to make a fast, super fast DC charging stations with high speed material, right, in the lithium ion batteries, such that they can have very high energy density capacity, and with less less size occupation. This is the present scenario of the batteries, right? Available batteries. So suppose if there is any other system that comes right in the battery system, like a hydrogen fuel cell. So this is the next fast is the hydrogen fuel cell, right? Where the hydrogen fuel cell it is directly give to the charge the battery. That is the conversion of hydrogen fuel cells, right? Or the different materials are used for take the hydrogen, right, as a fuel, and this hydrogen is converted into the electricity by using the hydrogen fuel cell, which is having a different technology in place of batteries, right? So therefore, we'll have a different technologies will be developed when are used in the latest generation of electric vehicles. Right. So recently, there are many companies like Tesla, Toyota, Sierra, then uh, there's a many Benz car and BMW cars and many things. Many the companies are came forward to incorporate artificial intelligence techniques, right, in the battery management system and traffic vehicles, only related to the electrical systems. That is charge stations and using non conventional renewable energy sources like wind energy, solar energy, right, and different types of the gases that we used to convert the electricity, right, to convert the non renewable energy systems into the electricity, and that is given the charge to the electric vehicles. So therefore, the artificial and machine learning technologies are having wide demand, right, in the research areas in the future in the development of electric vehicles. Right? So this is the conclusion that is I'm going to give that where the machine learning techniques have the wide applications in the uh, mm, electrical management system. So similarly, this AI and machine learning can be used in the software for controlling the entire vehicles, right? Vehicles can be used with the different predictions and important that, right? Therefore, total electric vehicle can be used with AI and ML techniques, right? So with this, I conclude the uh, the session and uses of this techniques, right? You can have a wide research areas, right, in this, and you can do research work on these things, right? Thank you very much for patiently listening this information, and thank you to all for this. Suppose you have any queries and anything that you can ask now, or you can also post the queries and then I can answer them right in later, right? And also how to do the research work and all these things that I can help you. Suppose if you come with some innovative ideas on these technologies. So thank you very much for patiently listening. So if you have any queries, you can ask them.
Dear participants, if you have any discussions or queries, please address to the principal, sir. So this brings us to the end of the session. Thank you, sir, for your valuable insights. Thank you for giving me this opportunity.
So thank you, Mr.
Thank you, sir.
Thank you. Thank you, sir.
Yes, sir.